And then is it?
You just go to that tab right there. You can. Present.
Oh, you got it up. Perfect.
You can just present your screen whenever you're ready.
Okay.
Yep.
Looks like
it's present, and then you can go there.
Perfect. All right. Good evening, everybody. Let me get a picture of everybody here so I can put this on my Twitter. Are you okay with that? It's funny because there's actually quite a few people here, but because you're all spread out. All right. There we go. All right. So, anybody see the tornado yesterday? 2. Anybody else? One in the back. Okay. Were you? I assume you guys were active, right? Because I was in the middle of the newscast. So but it was an interesting day. I need to be over here, don't I? Sorry. Oh, I see. Oh, you switched it. I'll stand here. I'll pontificate from here. Not really. As my wife would tell you, it's really not worth it anyway. So. The day yesterday, the one thing about Elsa was people were saying, must have been a really long stretch. It really wasn't. Elsa at least moved along. So I got home yesterday morning at, I guess it was about about 1 o'clock actually. So I didn't get up until 6. So that's actually a long stretch for me before I had to come in and work all day yesterday. So I had actually managed to get some breakfast and a shower and a new set of clothes on. So it actually wasn't that bad a day, although it was long. Started at 8 in the morning, basically. So I actually started at home at 7 in the morning because I do have a home radio studio that I can work out of. And then I got home this morning at 1 o'clock. So long day. And as I told my boss today, he asked how I was feeling. I said, well, I don't recover like I used to from these kinds of shifts. Used to not be a problem, but it takes me a little while. I will admit I felt like a little bit like I got hit by a Mack truck this morning when I finally, like my Roger's truck. Where is Roger? No, your truck. When I got up this morning, but I worked out the kinks and we got going. So we'll talk a little bit about that and that storm. I'll be curious to see what your observations are and your questions that you have on it. We'll talk about the season ahead. Dr. Klotzbach at Colorado State University just issued an update to his forecast for the season, so we'll check that out. There was a question here when I was sitting here about kind of where the state of broadcasting is going. We can talk about that a little bit too. Weather forecasting specifically, I think, is what we're interested in. So we can talk about all that good stuff. Anything you want to get off the top of your chest, off the top here, before I go? Okay. Yes, Billy.
I'm watching the different outlets. I was struck by how much better the modeling is with all the colors popping up on the screen. I think that's much better than it's ever been. Might tell us a little bit about how that works.
Yeah.
I think that debris thing, that folks out is pretty good now.
We're good. What's that, Roger?
The debris field map. I've never seen that before.
That's interesting, and we were talking about that. Ross and I were talking about that. That's another good one. We don't usually see that in Jacksonville. You can see that in the Midwest quite a bit, but to see it yesterday was pretty stunning. I want to say, and we saw the second one too, Kings Bay base, same way. I saw one in Georgia several years ago in a winter outbreak of severe weather here, which you don't see it here very often. So yeah, we can touch on that one too. And yeah, there's a lot. Presenting is so different. Well, I compared, leading up to this storm, I thought it looked to me similar to Bonnie of 2004. So Bonnie was a relatively minor tropical storm that developed over the Gulf in August, moved into the Panhandle, moved east-northeast, and dropped an EF2 tornado on the northwest side of Jacksonville. You guys might remember that pretty well. Any of you guys that have been going with this for a while, yeah, you remember it. Welcome. Good to see you. And so, and Bonnie then moved east-northeast, cut across the Panhandle, kind of northwest Florida, Georgia. So it was very similar to Elsa, really in a lot of ways. Elsa came in a little tighter to Florida. Arguably, I mean, it became a hurricane briefly Tuesday night. I don't know that it truly was a hurricane, but whatever. It was a hurricane for a couple of hours and then back down to a tropical storm, weakening as it came across. But as we all well know, it doesn't have to be a big system, big hurricane or tropical storm to drop tornadoes, and that's exactly what it did yesterday. And it just reminds me so much and reminded me of Bonnie, and it is really the way it behaved. Bonnie, though, didn't dump quite as much rain as Elsa did yesterday, but it was very similar otherwise. And it was an interesting day in trying to predict how this was going to behave because the initial band in the morning came through and dropped some heavy rain and gusty winds, kind of dropped a tornado in western Baker County, Lake City. moved on into Georgia, produced some severe weather, and then we went into a pretty decent lull that lasted for several hours as Elsa then came ashore. And then once the core of Elsa got a little closer, then that real big heavy area of rain moved in. Now, the question was, would there be enough instability during the afternoon to create tornadoes? Because at first, it was a solid sheet of rain moving across. But lo and behold, about 2 in the afternoon, 3 o'clock in the afternoon, the bands started to separate themselves a little bit. There was a little bit of a brightening of the skies between the bands. There was a little sun, and that was just enough instability to give those bands the extra impetus that they needed to produce severe weather and tornadoes. And we started to see the lines actually start to develop little cells. And then that's when we were like, uh-oh, we probably have some issues here. At about 3:10, I broke in. Hello there. At about 3:10, I broke into, oh, you know what? I brought a couple of umbrellas. We'll have to give the umbrellas away, Roger, before we're done here. So, at about 3:10, Corey and I, Garrett and Alyssa worked the morning shift. And then I came in at about 8:30 and worked some radio upstairs with them. The radio's in our same building. And then I came down and worked with them for the rest of the morning. Corey came in at about midday, and we all did the noon show from noon to 1. And then I cut Garrett and Alyssa loose because they come in middle of the night. So it had already been long. So then Corey and I held down the fort, I guess you could say, in the afternoon. And the first couple of hours, pretty quiet until those bands started to develop their individual cells. And at about 3:10, we're looking at radar, and we're like, man, those things are rotating. There were no warnings from the National Weather Service. And so I said, I'm going to break in on those because it just looks to me if they're not tornadoing, they're going too soon. So we did. We did about a 5-minute break-in spiel, and not unbeknownst to me, one of the rotations was already producing a water spout near Green Cove Springs. I don't know if you've seen the video, but a big water spout going up the St. Johns River. So my boss comes back and he's like, well, I guess that was a good idea to break it. I'm like, yeah, because I think we're going to have tornadoes. So, and sure enough, of course, within an hour, we all know what happened after that. So then we started to see better rotation with the storms, or worse rotation, depending on how you look at it. And with Doppler radar, and then the first tornado warning was issued at about 4:30. At that time, Corey and I, we've all got a pretty good system set up between Alyssa, me, and Garrett and Corey, where we pretty much can follow each other and figure out what one's going to do or need. And if we don't, we just say it on the air. It's a very comfortable working situation. We all work very well together, I think. And the lucky thing yesterday was that we had decided we would have the steady cam in the studio, which is basically a guy with a big camera on his shoulder. I mean, it's about a 30-pound setup. But what it does is it allows us just to move wherever we need to or want to, and people can see us literally getting the information as we're talking about it. Well, that was a godsend because I didn't have to stay really in one spot. We've got it marked with cameras in several areas, but it still kind of limits you. But it didn't at all in this case because we had the steady cam. So when the warning came out, I could move around I got different computers showing different things, and so that was very, very helpful for us. And then when the tornado warning was issued, we went through all of our protocols that we go through to try to find the tornado. It was not difficult to find the circulation, but it didn't look to us like it was touching down. And the first thing we look at is rain. Well, that's not a real good indicator of rotation and where the circulation is most times. There are exceptions. And then you look at the velocities, the wind. And that's the next thing you look at. And we looked at the wind, and there was wind there, but it didn't appear to be rotating. So it didn't look to us like there was a tornado yet. Or when I say rotating, it didn't appear to be rotating on the ground. We could see it at cloud level. And you probably remember yesterday with the tropics and tropical systems, the base of the clouds are very low. Especially when those bands come in, they can be a few thousand feet off the ground at the most. So they're really quite low. And then the next thing you look for is what's called the CC, the coefficient for precipitation in this case. And what we saw with that was nothing at about 440. So what that does is it shows us debris when it's being lofted into the air. So the way it works, though, is really quite interesting. We just try to stay here, don't I? Sorry. We got to kind of stay. We got to have to trick the radar to show what we want to see when it comes to tornadoes and that debris ball. So what happens is, and this was kind of developed, Doppler radar was developed years ago. The first operational Doppler radar in Norman, Oklahoma was in the 1960s. I actually had an opportunity to work on it in college in the 1980s. So it was the only operating Doppler radar in the lower 48 and one of the few in the entire world at the time. Now they're all over the place. But about 15 years ago-ish, I want to say, the Doppler radars around the country were upgraded to include pulse radar using microwave signals that are much more sensitive and allow us to see particles that may be very tiny very, very well. So we can see birds, we can see bugs, that sort of thing, dust, and then, of course, rain, too. What that coefficient property does for us is it allows us to see those particles, raindrops, dust, bugs. Those all look the same to Doppler radar. So when you look at it on the CC, on this coefficient radar imagery, and I don't think I have an example of it here, but anyway, it'll all look the same. It doesn't change much, and then you know that it's just there's nothing really there, so to speak, when it comes to tornadoes. Now sometimes it can look real messy. You might have spikes. You might have, and that too is just noise. You know, we know that's not a tornado. But when you have everything that looks uniform, and then right in the middle there's a little area of different color. In this case, it's usually it's a gradient from kind of a gray to a pink to a purple to a yellow and reds and blue being the biggest objects. When you all of a sudden see a round circle like that, the radar is like freaking out because now it's got much bigger objects. So instead of seeing rain and drizzle and bugs and birds and stuff that's all relatively the same size, relatively, and it doesn't make the radar beam bend, tilt, or pulse any differently. But when you all of a sudden start throwing in a rooftop or trees or whatever else it's going over, now it's like, oh, wait a minute. And now that signal is remarkably bent, of course, and changed, and it changes its appearance on radar, and that's called the debris ball. And that's what we saw yesterday. Very rare in Jacksonville. Very rare. But it happens. It is newer technology, not brand new, but newer technology. You can also see how far up into the atmosphere it's being lofted, although we did not show that on the air last night, and I told Corey that's one thing we should have done. But when you're in the mix of it all and you have a tornado on the ground, that is not a life-saving tool. That's just telling me how strong that tornado probably is. But I know there's a tornado on the ground, so it's not that it's meteorologically and you guys would understand, right? It's really cool to see. But at the time when I'm tracking it street by street trying to protect people, that it's, I shouldn't be concerned about the neatest thing out there, right? So so we saw that debris ball. Then we knew tornado on the ground. That was at 4:50, and at 4:52, the National Weather Service identified the debris ball as well. And then the strangest part of it was I wasn't getting any damage reports initially, and I thought, well, man, that just, Corey and I were confident that was a tornado. Yes.
Y'all have anybody at the station monitoring the radio?
Great question. We used.
At the time where it was going on when you were on the air, I was listening on WKB. I mean, there was operators actually calling out free field. I actually seen free circulating in the sky and stuff like that. It's pretty far area.
Right, and that's a great question. We have in the past, and now you guys, Raj, you guys have a website I can go to, right? So I can actually get that information as it's being relayed to you guys.
What you wouldn't have time to do it. I was looking at TV also. It was amazing to see what you were describing what it was coming to. As soon as that debris field popped up, I heard these guys on talking about Bowden Road, and
right.
It was absolutely simultaneously.
Yeah.
It was a perfect picture.
Right,
I don't know how you guys did all that at the same time.
And that would have been, it was a pretty. Right, links. It was a pretty remarkable period there, and then at about 4:55, I've got a guy on Twitter that tells me he just ran over a bunch of metal, or ran by a bunch of metal on the interstate on a 95 in University or somewhere in there, very close to Bowden, and I'm like, okay, well, that's our first hint that there's probably more damage or something there. But then there was another 5 minutes went by. It seemed like a long time. It might have only been 5 minutes, but it seemed like a long time before it really started to get much more. And then, of course, the reports did start to roll in. But at the same time, I also have to make sure I don't still have a tornado on the ground. As excited as the newsroom is to get pictures and video up, my job is to make sure you all know where the tornado is and everybody out ahead of it. So I'm tracking. I did become pretty confident within 5 minutes or so that we didn't have a tornado on the ground, but a tornado warning technically was still in effect. So it did lift after 3.5 miles, I think is the final mileage on it today, this afternoon, that the National Weather Service came out. Scott Cordero did the Duval tornado, and Al Sandrick did the Southeast Georgia tornado. All right, so this storm moves about due north, slightly west of due north. And another interesting thing about it is when Corey and I went on the air at one point, I want to say it was 4:15, we saw another big circulation on the St. Johns River, actually by Switzerland in St. Johns County. No reports of anything under it. We're just shocked, but we tracked it, and it took it to Mandarin at like 4:45. So it was the same cell. So then that cell went in, produced the tornado in Duval County. It moves a little west of due north and kind of reforms and kind of bows out to the northeast through Nassau County. And just as it does that, it's about 5:30, and we have actually a video of this. I said to Corey, I said, goodness gracious, look at this St. Mary's, Georgia storm. It started to put out a bunch of lightning. That's another key thing you look for, you guys, in the tropical systems, is like a sudden storm that has a lot of lightning. That's an indication of one that's probably going to rotate and tornado. And I'll mention, I talked about that debris ball. I want to talk to you about how different the images look like on radar in a tropical system situation versus like an afternoon thunderstorm that we typically see if it's got a tornado. So the St. Mary's storm starts to take off. It's the same cell that had moved through Duval County. And it starts to just lightning like crazy. So we're on the air. I said, let's take a look at the winds. So Corey switches it to the winds. We can't really find any rotation. We do find wind, but it doesn't appear to be rotating. So we got to watch that cell carefully. And within 5 minutes, it starts to rotate. Tornado warnings issued for Camden County, Georgia. And within another few minutes, we had another debris ball. And this one is now south of Kings Bay base, moving just about due north. This debris ball was even more pronounced than the one in Duval County, so we were pretty convinced a stronger tornado, which it did end up being, an EF2 tornado. The Duval one was a high-end EF1, 110-mile-an-hour winds, 111 is EF2, so it was almost there. And then the Camden County one was an EF2 with 130-mile-per-hour winds, and that's the one that trashed that RV park. And, I mean, RVs are no match for a 70-mile-an-hour wind. Throw in 130 mile-per-hour rotating wind, you got problems. So that was the second tornado. We had several high wind events, of course, that were not unusual, and really the winds as a whole weren't too bad. We had said all along we didn't expect the bridges to have to be closed because the sustained winds weren't going to be 40 miles per hour, and that's how it went. Didn't happen. But unfortunately, the guy on the southwest side of Jacksonville, the tree dropped on his car. I mean, you know, talk about an unlucky day. Gee whiz. And there really weren't that many trees down.
5-year-old with a daughter.
Right, yeah. There weren't even that many trees down outside of where the tornadoes hit. There really were very few trees down. I mean, JEA had everybody up and running in the tornado area overnight. If it had been a widespread event with a higher end tropical storm or hurricane with more power outages, you know, we'd still be without power right now in many cases. So that's how that all went down. And I wanted to mention just on Doppler radar, and I know we've got some weather geeks in here, right? When you're looking at reflectivity, which is rain, and then you switch it to the velocities, when you're looking at tropical systems, if you're a real nut, you know that if you're looking at velocities on a thunderstorm on any given day, you look for the red up against the green. And that's because the particles, the raindrops are moving in different directions according to the radar beam, and it shows up. And if it's close to one another like that, we call it a couplet. The wind is blowing this way here, it's blowing this way here, it means there's rotation. You have a thunderstorm. And you hope that it's that easy to pick out. Sometimes it is, sometimes it isn't, but that's what you're looking for. The tropical systems, and yesterday was exactly the same way, aren't like that because they're so low to the ground. The cloud, remember I said the base of the clouds were maybe several thousand feet, and in some cases yesterday I saw them little more than 700-800 feet off the ground, the base of those clouds. So when you're in that situation, the radar beam is missing a lot of what it needs to see for us to see the tornado. What we look for then is a sudden bright coloring in the velocity field. So you'll go from what looks to be just normal wind, so to speak. All of a sudden, you've got a couple, usually multiple, 5, 6, really bright pixels. And that tells us we have a potential problem there with, if not a circulation, at least very high winds in that very small corridor. And it typically matches with tornadoes, tropical tornadoes, but they're low to the ground. There are a lot of times there's a lot of rain around them. The one in Duval County had a lot of rain around it. They're hard to see many times, and they move very fast, faster than typical here because they're being steered by the tropical storm and the hurricane, whereas now with a sea breeze thunderstorm, it might move 10 or 15 miles per hour. In a tropical situation, they're moving 30 and 40 miles per hour. So you don't have much time to react. They don't have any hail with them because it's a tropical system. The air is really warm all the way up to the atmosphere, so it doesn't hail with our tropical tornadoes like you see other thunderstorms that produce tornadoes. It will lightning quite a bit many times, but sometimes it won't. And there's no other warning other than that loud roar. And we did hear that from several people, and I kept trying to emphasize that you're not going to get many clues that this is coming in. There isn't going to be any hail. There isn't going to be any real, you're not going to really have, you may lose power, but by that time you got 5 to 10 seconds to react. So those are the things you're looking for. And we did have several people mention the loud roar. If it's, and we did see this yesterday late afternoon, but if it's in the evening and at night, especially look for power flashes from the power lines and the transformers that are going out. We did see that along Phillips Highway yesterday, but it was late afternoon. So, and we had some really wild video of it crossing Phillips Highway and transformers blowing up in the whole 9 yards. So it was there. And then it did cross briefly. It did cross I-95 at Bowden. I don't know if a lot of people realize that. And there was some tree damage, but we're really lucky there weren't any vehicles that were destroyed because the vehicles were no match for the tornadoes either. So it was an interesting day. It was a busy day. Otherwise, Elsa was what we thought it was going to be. Isolated tornadoes, gusty winds, heavy rain. It really, from as far as widespread infrastructure damage, there really wasn't much. And I use a tropical scale to try to give people an idea of what to expect. And I go from 0 to 10. 0 meaning it will have no impact. 10 meaning, it's shutting us down. It's severe. And I put Elsa at a 3. But I emphasized that if your house is affected by the tornado, well, now it's a 10. So it's all about perspective, right? For most of the people, it really wasn't even a 3. For the guy who's in the car where the tree comes down, that's a 10 plus, and his family. So I'm always a little wary about that. I get concerned about that, but I think it's a good way to communicate the message because people, I'll be the first one to admit it. I guess it's the media, but people freak out with this stuff, right? Oh my gosh, there's Elsa's in the Gulf, and it's going to come here. Well, sun's out now. We have power, and we're all okay. To try to get that message out there is remarkably difficult for some reason. So I try to be real world with it and emphasize that. And I get mixed results sometimes, admittedly. But it was an interesting day. The debris ball was huge on radar. We don't get that kind of signal on radar all the time. That makes it very easy, quite honestly. I heard reports of some, I guess the meteorologist couldn't find the tornado. And I'm like, well, if you can't find that tornado, you're never finding a tornado. I mean, that thing could have, it was like, hey, tornado right here. Here I am. So it was pretty easy to do, quite honestly. So I thought I would go through a little bit about what led up to this storm because, oh yeah, I'm just going to share, right? No, I share first?
Yeah, start share first.
Okay.
Wait, question, while you're doing that.
Yeah.
From Bonnie from this one, was Bonnie larger? I know in Bonnie in 04, that took pretty much out of the Kings from the McDonald's on Kings Road.
Yes.
Up Edgewood Ave, up by the high school.
So you're talking about the tornado from Bonnie, right?
Right.
Yeah, that tornado was almost an EF3, which is very rare here. So it was bigger. It was stronger and bigger. And there were several homes destroyed with that particular tornado. In this case, there weren't homes destroyed, but there were some apartment complexes hit pretty hard. There were some roofs off industrial buildings, but that was one of the things. It was a largely industrial area. So that helped out for homeowners because there weren't as many homes in its way. And the Kings Bay base one, they were very lucky because that thing curled a little northwest after it hit the RV area. But those RVs were just were trash. That was a bigger and stronger tornado, the Southeast Georgia one. So what I thought I would do, I'm actually going to go to Talking to Tropics. You guys know about the forecast models, right? You hear about it all the time now. There's a lot of hoopla out there about the forecast models. Trust me, it's blown out of proportion. But this one was interesting because for whatever reason, and there used to be good reason, it's not near as good a reason now, people would always hang on the European. Oh, the European is the almighty. Folks, this just in. It ain't. All right? It ain't. It's been going downhill for several years, and the GFS American model has been rising to the top. Now, there are no perfect models. I mean, and people get on my case for missing a forecast, and I'm like, are you serious? Do you think it's just cut and dry? You think it's got 100% accuracy? It's a forecast. I can forecast how many of you people are going to leave at what time today and tonight, and I'm probably going to be wrong most of the time. I can forecast what the football season is going to be, how many Jags games, how many games the Jags are going to win. It's just a forecast. I can predict what time I'm going to get back to the station tonight. I may be wrong. They're inexact. Well, the weather's even more inexact. They're just models. They're just forecast models. And what I find a lot of times is the younger people that come out of college, they're model driven. And that's a problem because the weather isn't nice and neat and contained by a little glass and it all behaves just exactly right. And the way the models think, the models in some cases have no clue. I always say, check it before you say it. So all the time I go out there, people laugh at me in the newsroom. I go through the newsroom, I trudge to the door and I look out there to see what's going on. No better way to check the weather. So, and actually you'd be surprised how many times I've used our Skycams. We have about a 7-8 Skycam network around Northeast Florida and Southeast Georgia. How many times I have forecasted the development of a thunderstorm on Seabreeze just using the Skycam. Never looked at a model. Never didn't even look at radar. There wasn't anything on radar. But I can be within 15 to 30 minutes of a thunderstorm developing just by looking at the sky. So that's a lost art, unfortunately. But anyway, so my point on this was the European model had no clue on Elsa. I'm telling you right now, the European agency is like, oh my gosh, what's going to happen now? Because for quite a long time, the European didn't even find Elsa, didn't even know it was there. The GFS model did. The GFS model insisted on the Eastern Gulf and then moving northeast. Well, case closed. That's exactly what it did. And then through the weekend, the European model wanted to take it east of Florida. Well, now I got all these people tweeting at me and calling to me and emailing me saying, did you see the European? It's going east of Florida. I'm like, did you see what the European had yesterday? Or do you see how it's, and what you do, the key is you look at what the analysis is for the model. What is it showing when that data is going to be inputted and then to tell you what's going to happen 24 hours, 48 hours, 72 hours, and beyond, what's it showing right now in its analysis, what we call the initialization of the model to come up with its forecast. And if the initialization is bad, then the model data is going to be bad. It's like, if you put something bad in your body, bad stuff generally comes out. All right, so I emphasized, I'm like, well, the European model doesn't even know the storm's there. So if it's taking it east of Florida, it's meaningless. Now, that's a little gutsy because there's some people that are the Euros had some good calls. And there are some people that would just completely go that way and never think twice. And there were some that did. There were some local forecasters that took it east of Florida over the weekend. Oops. So then the European finally kind of figured it out Saturday afternoon and Saturday night. And then basically after that, all it did was follow the GFS. And they were basically outside of a few hours off or maybe a few miles. There was nothing dramatically different about them, except that the European was stronger at landfall and stronger through Georgia. And that didn't turn out to be correct either. It was almost at hurricane strength in Georgia. It's supposed to be, and of course it wasn't anywhere close to that. So anyway, the GFS wins this battle, which is kind of interesting because that's a battle that's been going on for many, many years. Now, will it get the next one? Which one will get the next one is the $1 million question, and we don't know the answer to that. But I will say that generally, what you do, and I start looking at what the models are doing in the tropics in the spring in the Pacific. So how are they models predicting and handling tropical systems in the Pacific during our off season, during what would be the spring season of the Pacific? And usually that gives you a hint leading into the Atlantic season in June through November. And it did this time around. And usually you can tell what models are going to have a better time of it. And so in the next storm, if all things are equal, one would have a tendency to think, I should lean on the GFS a little bit. Now, when I say all things are equal, again, you have to look at that initialization. Does it find the storm well? Is it diagnosing the situation right now very well? Or is it missing the boat? And if it's missing the boat, then its forecast output is probably missing the boat too. So we'll see how that pans out. But it was an interesting forecast. It was a difficult forecast. I had people paranoid about it becoming a rapidly intensifying storm. It was never my concern. But having said that, you got to be careful in the weather world. Obviously, never is a tough word to say in weather and on TV. So it's not like it couldn't have happened, but nothing indicated that was going to be the case because it was moving over shelf water of the Eastern Gulf, which isn't particularly deep. It's still only early July. The water's not near as warm as it'll be in 1 to 2 months. I'm telling you right now, Elsa would have been a much bigger deal in the middle of August through the middle of September, early October. Also, there was a good deal of shear. A lot of people seem to ignore that, but it was quite clear there was a lot of shear with Elsa all along. All the heavy rain and storms are to the east of the center. So there was west winds blowing through Elsa, and tropical systems don't like shear. It's also one of the reasons why it was pretty intense for us from a heavy rain band standpoint, isolated tornadoes, because everything was on the east side of the circulation. And there was a certain amount of dry air. And the closer, which is the enemy of tropical systems, and the closer tropical systems get to land, the more dry air they ingest because they're getting closer to land. It's not a tough forecast. You see it all the time. And so it eats away on the western and southern part of the circulation as the storm's making landfall. We see that happen all the time. So that was not a difficult forecast either. So that meant that once the center was at and past Jacksonville's latitude, it was going to clear out, which it did at 10 o'clock last night. Okay? So all those things needed to be taken into account and factored in, and what was not an easy forecast from the beginning. And it's also more difficult because it's going to affect us. So you got a lot of extra ears, a lot of extra eyes, and I'm supposed to tell you what's going to happen. And I want it to be right. And I wasn't calling for a major hit. Now, again, the guy in the car, that's a major hit. But for everybody else, it wasn't too bad for the most part, unless you were in that area that was hit by the tornado, of course, which I tried to emphasize on my impact scale. I put on there tornadoes. It's a 3, but if you're in a tornado, it's probably going to be much closer to a 10. But the percent of the population to be impacted by a tornado is going to be 1% or so. Tornadoes just aren't that wide. The Duval County tornado was on the ground for something like, I want to say a couple of miles. The Georgia tornado on the ground about 3.6 miles, which by tropical standards and Northeast Florida, Southeast Georgia standards is relatively long. But again, in the grand scheme of things, we cover a viewing area that goes west to Lake City, south to Palm Coast, north to Waycross, Georgia, and Brunswick, Georgia. It's a fraction of that area. So I'm just going to pop up here real quick. If anybody follows Talking the Tropics, you'll see what I'm talking about here. And I would recommend it, not because it's selflessly promoting my things, because, at this point in my career, if you want to, great. If not, quite honestly, great. But this will help you. Even people in the station will read it. This gets much more play when of course, there's something busy going on. This was my latest one, which is not really the one I wanted, to show you what was going on in the tropics. So I'm going to take you back to one that's Elsa moving in, talking about Elsa headed for the Florida Big Bend. That one might be better. Yeah, we'll go with this one. So I'm going to open this up and just show you what we were looking at for in forecasting. I'm not going to look too much at what was going on at the time. I'm more interested in the forecast. I almost always start out with what's going to happen here locally. And sometimes that's a sentence. No impacts. Other times it's much longer, like you're seeing here. So I have in here, this was on Monday, I believe, that I wrote this one. I updated. It depends on what's going on, but during Elsa, sometimes it was 2 and 3 times a day. So it will be updated. Sometimes it's relatively cosmetic updates. Sometimes it's bigger updates. It depends what's going on. So I said it's going to move inland over north central and northwest Florida on Wednesday. Jacksonville impacts are mainly Wednesday. Heavy rain at times, some flooding, gusty winds, and isolated tornadoes. This does not look to be a major hit on the local area, but remember that there's no such thing as justa, as tropical storms can cause damage and injury too. Respect the weather impacts, and the forecast remains virtually unchanged, especially given the forecast track, despite the model strengthening this Tuesday evening, which was the hurricane briefly coming. And the people freaking out when that thing went hurricane in the Eastern Gulf was amazing to me. And one thing I would emphasize is that a hurricane has winds of sustained 74 miles per hour. A tropical storm, high-end tropical storm, has winds of 73 miles per hour. There ain't no difference. It's just semantics. I mean, it's sort of like saying, okay, I'm walking outside today, it's 90 degrees. But tomorrow's going to be 92, and that's just going to be a bear. It's the same dang thing, right? Okay, so that was a message I had to try to communicate. Given the forecast track, winds Wednesday will average 20 to 30 miles per hour with gusts 40 plus. It was just about right on. I did narrow it down to Highway 301, 995. I tried to break it up a little bit. Mentioned Waycross and Lake City because they'd be closer to the center. Mentioned that there's really no storm surge with a storm like this. It's also interesting to me, a lot of people were worried about storm surge, and a lot of people had Irma flashbacks. And I get that. I mean, Irma was a disaster for downtown, for the Black Creek area, and those people were kind of freaking out because this did have kind of an Irma path-like thing going. But Irma came in a little more from the south to north, so it came up through the Keys, where this came in a little farther to the west and certainly was much, much weaker than Irma, not near as big. So I was confident, so confident that it wasn't an Irma repeat, that I made a graphic that said, here's what Elsa is, and here's what Elsa is not. And one of the is nots was Irma. It's not Irma. So hopefully that was a way to communicate what I was seeing and expecting here. But it was, the communication of it is so critical, I find, over a period of time. It's very interesting to see how people react to what you say or don't react, and then what they hear and what they don't hear. It's one of the reasons I like talking to topics with Mike, because you can go back and check me. I mean, if you think I made a crappy forecast, it's all written out. They're all saved back to last year. And sometimes they are crappy. I'll be the first one to admit it. So this does at least give, it gives us something to look at and go back and look at. Rainfall will average 1 to 2 inches, but as much as 3 inches plus. I wish I'd have been a little higher there. Wish I'd have been like 1 to 3 inches and then plus. But it falls within the realm of where we generally were. And I didn't believe it would be enough to flood Black Creek, and it wasn't. I wasn't particularly worried about most of the tributaries. Even though you had a lot of water in the system and plenty of rain, Elsa was steady moving, and as long as it didn't stall, and we didn't have a real good east surge of wind on its east side before it moved in like we did with Irma, which all sets the table for a lot of water in the system, both natural, as in from the sky, and salt, as in from the ocean. But we didn't have that kind of setup this time around. Then I have usually a lot of graphics. There was one missing here because it's now past the storm, and then I will go into the really meat of the forecast. Why I've got the forecast I have, what the models are doing, and it can be very in depth, and so that's what all this is. And I mentioned, I think I go right at. I talk about the GFS. Then I said the European model has been having a tough time finding the wave that's become Elsa. Then tried to take the storm east of Florida, but has been trending better recently and finally seems to be in the game. The model has been variable on intensity and now is one of the stronger models, a solidly moderate to strong but compact tropical storm, showing Elsa moving north-northeast across northwest Florida, pretty close to the GFS track, which, as we all now know in hindsight now, was the case. The UKMET model, UKMET model from United Kingdom, can be sometimes a good middle-of-the-road model. And I like to only use about 4. 3 is perfect world if it's a well-behaved storm, because you can find models that take stuff all over the place. After a while, you're so confused as to where the thing's going. Like when they show the spaghetti plots, right? I'll show them, and it never fails. There's one that's just like wild. Okay, it's like let's say that this is a hurricane making a beeline for Mexico, but then one will show a curve to Jacksonville. And people will call me like, you see it's coming to Jacksonville? You see that model? You know, you just can't do it that way. You can't, 9 out of 10 times, consensus of the models is the most accurate forecast. It's amazing how well that works. So then I'll throw in a bunch of graphics here, and they're not showing up today too. Well, there's some. So there's where Elsa is now, by the way. It's going to move across Chesapeake Bay tonight. And it is a low-end tropical storm still. It's stayed relatively well organized, and now it's kind of sniffing that water, warm water again over the western Atlantic. So we'll strengthen a bit tonight and tomorrow. Not a lot, but again, it's well past us. There's the winds, expected time of arrival. There are all the warnings that are in effect. There's radar imagery. And then I go to, let's see what's up around here now. Nothing at all right now. Okay, that's good, because I'm here. And we have to be at the station. There's a lot going on. All right, so then there's wave heights. This is where tropical cyclones are forecast to develop over 24 to 48 hours by computer models. This is the dust cloud. You hear all about the Saharan dust, right? And how it's just been awful, and all of a sudden there's a lot of Saharan dust. Folks, there's been Saharan dust since this earth existed the way it does. All right? The way the world works and the weather works, for thousands of years, dust has come off Africa, goes across the Atlantic, drops some dust in the Caribbean, drops some dust in Florida, and that happens every year. Every single year. Now, the magnitude may be different, but it happens all the time. For some reason, this has just become a big deal recently. I think the World Wide Web spreads this stuff. But anyway, it happens all the time. So where you see the bright colors, that is dust. And near Florida, there's a lot, Africa, there's a lot of dust because that's coming right off the Sahara. So that's what you'd expect. That's where your biggest dust cloud is. And then it kind of thins as you go west. But there's actually a fair amount of it out there right now. So what a rough correlation is, if there's a lot of dust, the air over the Atlantic is typically, where that dust is typically a little more stable. It's a little drier, and it's not conducive to tropical systems in a very vague and general way. But there's a lot of people that out there will be like, oh, look at that. It's not going to hurricane for maybe years now because there's big African dust out there. Well, no. This changes all the time. Again, like I said, there'll be, and it's always thickest in June and July. It was very thick last year. We had a couple days here where we had a lot of African dust, sunsets, and it was hazy and all this other stuff. And people are like, oh, it's not going to hurricane all season. Well, we had 30 of them in the end. So that's not a good correlation. And what happens a lot, and I saw this plenty of times in the 2005 hurricane season, which was an infamous season. That's Katrina, Rita, Wilma, big, powerful hurricanes, right? Is what they'll do, and you can see it even here now, is they'll go underneath the dust plume. You see those white little balls of clouds? Those are African tropical waves that are coming off the coast of Africa. And they're in a pretty favorable environment right now. They're away from that dust. But what will happen sometimes is they'll just go through that dust. They'll not do much because it's dry. The air is dry. And they just kind of keep going west. And then they get west of the dust plume. And now they're like, oh, wait a minute. There's humidity here. There's moisture here. And if conditions are favorable, they just start to strengthen. That dust cloud didn't do anything to them. It just delayed the development. That's it. So you have to be very careful with what you see and hear on that, but because it's not a good steadfast rule. And the dust will have a tendency to break up some here as we go through August and September in particular. But Elsa, interestingly enough, Elsa was an African tropical wave, and I point that out because we get them all the time in August and September, almost never in June and July. So to get something to go across the Atlantic like that and develop, to me, is a warning shot for the next few months. That, we've got some problems here, probably in the U.S., given where the Bermuda High is, in the next few months. It's going to be busy. And I have to move in August, I have some time off in the middle of the month to move my kids to college. Guarantee you there's a storm that week. Guarantee you. I'll be called back. I'll be like, kids, have fun at college. I'll see you when I see you. So we'll see. Next name on the list. Oh, that's good for an umbrella. What's the next name on the list? We just got Elsa. You rotate the names in alphabetical order, male and female. What's the next one?
Fred.
Oh, somebody on here got it. Who was that?
That was me, Mike. Paul.
Mike who?
Paul. Paul got it.
Oh, Paul got it. Can you get this to Paul? Paul, is there any way for us to get an umbrella to you?
Oh, yeah. I'll hook up a rod to you.
Good point. Paul gets an umbrella. They're going to deliver it to you somehow. All right. Very good, Paul. That's impressive. All right.
Thank you.
So yeah, we can send you a picture of the umbrella while we're using it for the rain. All right. So anyway, all this data is here. All this information is here. And I do find it helpful. I do spend a lot of time on it. Yes.
Oh, I'm sorry.
That's all right.
I get the impression that these models are under continuous evolution to improve them and so forth.
Right.
Do they do that continuously or at season end for the next season?
Right. That's a great question and a great point. And the answer is yes. And they generally wait until between seasons, although some of them, a lot of them aren't just tropical models, so they don't necessarily have a season. But the GFS model was, and I didn't realize it until I went to the hurricane conference last month and talked to the Hurricane Center. The GFS model was tweaked a little bit during the spring because it was felt that last year it didn't pick up enough of the storms in the early stages. So the question now is it going to pick up too many? Was it tweaked to the point where it's just going to go doing, 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 everything's going to be every low pressure area is going to be a tropical storm or a hurricane? So far, we haven't seen that, so we'll see. And then the European model was tweaked because it was felt that it was under forecasting its seasonal forecast. In fact, it was way below last year's at real numbers, and it was low this year. And so they've tweaked that so it'll come up a little bit. But yes, the answer is yes. They tweaked the models, and quite honestly, I wish they didn't as much. I wish they did once in a while, but when you learn the subtle biases of a model and can predict it because of those out-predict the model because of those biases, it's actually helpful. But of course, the people running the models don't want you out-predicting the models, Lord forbid. So they're constantly tweaking them, and that does make it harder to forecast, and it makes it harder to know what biases they're going to have each season. That's why I told you I start looking at this stuff in the Pacific earlier in the season, earlier in the year, to see the kind of biases that we might be starting to see that could help us with the Atlantic, because they're never going to be perfect. They will never be perfect. They're the best they've ever been. There's some room for some improvement yet, especially in intensity forecasting, but they're never going to be perfect. So there's going to need to be this continuous attempts to tweak it. But yes, they do frequently tweak them. Yes.
How high is that dust? Does that affect the aeronautical?
Yeah, that's a great question. That dust is, when it's coming off the coast of Africa, it can be anywhere from the surface to easily 30,000 feet where jets are hanging out. So where you see that bright pink there, that's a really thick dust cloud. That's, of course, adjacent to the Saharan desert. So that wind coming off there, it's pretty easy to still have pretty thick dust. When you get to the yellows and orange kind of on the west edge, now you're talking elevated 20 to 30,000 feet and thin enough so it's not affecting air travel.
It's not like the impact of lava.
Ash. Correct. It is not. Typically, it is not. Yeah. Good question. Good point. Yeah.
I'm curious about the models, the differences between them. I'm sure each of them has different algorithms and analyses, processes that
Exactly.
they're running. But do they have different data inputs, one from the next to the next to the next?
Within the same model?
No, from one model to the next.
Yes, they do. Yes, they do. And so here's a model run for Elsa, which now they're really tight and because they know it's an easy forecast now. So, but yes, like for example, some models will analyze the oceans differently, and that data will be inputted differently. Some models will handle the physics of the upper layers of the atmosphere, which is only the troposphere for models, which means you're going to maybe 30, 35,000 feet. We'll handle that differently. And maybe use different values even. So yes, each model, and that's the secret. I mean, the Europeans are especially tight-lipped about their European model because for several years it was relatively superior. But
some of that data wrangled by people before being fed to the model analysis.
it is not. That's a great question. Is the model data is it messed with at all once that raw data is put in, and it is not manipulated by humans, at least not yet. Now, I can manipulate my model data from our vendor for our thunderstorms that occur here on afternoons if I think it needs to be upped or downed, but I can't physically move like an area of low pressure or a hurricane, which would be kind of interesting if I could and maybe scary. But I can just manipulate the rain so it lines up to what I think it's going to be. But how the models are manipulated during a tropical storm or a hurricane is once it's getting 24-hour plane surveillance, Hurricane Hunter aircraft, they will dump the data from those aircraft, which is sampling not only the hurricane or the tropical storm, but also the atmosphere around it, will be ingested in the model data, and that seems to generally help. However, I've always said, now the Hurricane Center kind of hems and haws with me on this, but I've always said that the first one and many times the first two model runs after that plane data is ingested are not very reliable because it's so brand new data. It's so much brand new data. I think it causes the model to hiccup for a 12 or 24-hour period, and then it smooths it out. Then it figures it out. Then it ingests it, and it starts to smooth out its output. So, yeah.
I have a feeling, I don't know that there's validity to this thinking, but I have a feeling after having lived here like 5 decades that forecasting in Jacksonville is harder than a lot of places. It seems to me that you have the Atlantic, Caribbean, the Gulf, and then the United States continent, northern continent.
Yeah.
And any one of them pushes a little harder than any of the others. And whatever you said is out the window.
That's true to some degree at least. And the sea breeze, especially this time of year, is very fickle. And it can be the difference of 5 to 10 miles of where that sea breeze is can be the difference between a drenching thunderstorm or maybe even a severe thunderstorm and not getting anything at all. So the sea breeze is especially difficult this time of year. Now, it's not too difficult the next couple of days because we have a west-southwest surface wind blowing from west to east. Well, the Atlantic sea breeze isn't getting inland very far in that situation. Today, it didn't move inland at all, so the beaches were 90 degrees. What we do have to forecast in that situation is the west coast sea breeze. So when it develops, it'll move all the way to Jacksonville, I-95 the next couple of days, and that'll trigger our thunderstorms. So I got to time out. I got to try to figure out that timing. So it is a challenge. The ocean makes it especially difficult, you're right, and it's especially difficult in the winter. Because when you're trying to predict storm systems coming in, the ocean plays a role. And when you're trying to figure out how cool it's going to be, that ocean plays a massive role, and the river, St. John's River, in what the temperatures are going to be or not be in cold outbreaks, for example. So yeah, there's a lot going on. The one thing we don't have that, let's say the Midwest has, which is where I grew up and forecasted initially, is the Midwest has all kinds of weather. The only thing they really don't have is a hurricane, but they have everything else. And I've seen it go from a tornado outbreak to a blizzard with a blink of an eye within less than 24 hours. I think actually the weather of the plains in the Midwest is tougher to forecast. But it ain't easy anywhere. And of course, we're going to miss it sometimes.
One thing that, well, the two things that you mentioned in passing, you were covering many things during the broadcast yesterday.
Yeah.
One was that the tropical systems seem to have less lightning than non-tropical systems. Right. Because of the humidity or moisture in the air, kind of like short-circuiting the buildup.
Man, you were listening.
Charges or whatever, possibly. And then another thing that you mentioned had to do with the difference of the picture presentation from the radar versus presentation from satellite. They would not be in sync because of lower level versus higher level information. Right.
Good point.
Both of those were interesting.
Yeah. Tropical systems in general don't have a lot of lightning because there's very little particle separation because they're so saturated. There's so much moisture. But sometimes when the hurricane or tropical system is rapidly intensifying or is about to do so, you'll get a lot of lightning near the center. And we did see that a couple times with Elsa during the past week. So that's one clue and something to look for. And then I mentioned sometimes before they're going to tornado, you'll get enough charge separation because the cloud has just bumped up enough, intensified enough to develop a little better particle separation, better electrical charges that are between your positives and negatives, and then you get lightning, and that's when you know you've got a strengthening storm and will at least get higher winds and maybe a tornado. Yep, good points. Exactly. Anyone else for the moment? I thought it was, yeah.
I want to circle back to the modeling. My thinking is, you're talking about adjusting modeling data. Do they ever go back to previous storms that they know the track and what happened in the past? Yep. And put that data into their readjusted model to see if it correctly forecasts something that they already knew that happened?
They do every year. It's a great question and a good point. So the model data after the season in post-storm studies, they will go back in and ingest that data and see how the model does with tweaks and changes compared to reality. You bet they do. It's really become popular in about the last 15 years. And doable because that takes a lot of memory and information. That's a lot of stuff going into computers, and computers just simply weren't able to handle that magnitude of information, that input, until relatively recently, in the last 15 years or so. But yes, they do. You bet they do. And they get mixed results. So, all right, so let me just briefly go over the season ahead. So, Colorado State University, Dr. Klotzbach, if you're familiar with the hurricane forecasting, used to be Dr. Gray out of Colorado State. What everybody asks me a lot of times, they're like, why is Colorado State forecasting hurricanes? They're in Colorado. But Dr. Bill Gray, when he founded his hurricane research division at Colorado State University, he simply went to the university that was willing to fund him, which happens a lot. That happened to be Colorado State University. So that's where he's done all of his work. It's mainly forecasting work, a lot of research on how hurricanes develop and move, but the big thing is seasonal forecast. Take it how you want to. Seasonal forecast, the value of them is debatable, obviously, because really what we want to know is what storm is developing, when's it going to hit, and how big is it going to be. Well, we can't do that very far in advance these days. And so a seasonal forecast, you kind of question the value of it, but it will give us a hint typically as to what kind of season we can expect. And I'll give you an example. 1992, 6 named storms. And if I were to say, hey, we're going to have 6 storms all year, you'd have been like, piece of cake. But one of them was Andrew, Cat 5 that hit South Florida. So you got to be careful with those numbers. And even last year, I would argue that after 30 named storms, we really did not suffer in the U.S. near as much as we could have for 30 storms. Now, the area that was hit by Laura in southwestern and western Louisiana, still rebuilding. There's years of rebuilding there, admittedly. But think if that's 50 miles east and it's New Orleans. Think if it's 30 miles west and it's Houston. You have a completely different magnitude of a storm and damage. Now, Central America, Venezuela in particular, was hit really bad last year, and generational storms for Central America, not Venezuela, that's South America. So the area, Guatemala, Belize, a little south of Belize, Honduras, all these areas, really, generational storms. They're going to take a long time to recover. Just like the Bahamas after Dorian, still picking up. Dorian was a nasty, nasty hurricane a couple of years ago. Panhandle, Michael from 2018 will be picking up the pieces for a long time, although they've moved forward pretty well actually recently. So anyway, Dr. Klotzbach at Colorado State University upped the numbers by 2 pretty much across the board today. So and this is off the top of my head, I think he's got 20 named storms, but 5 of those have occurred already, right? We're up to Fred, as we just heard.
He has a chance to up it again.
Well, I could, yeah. But he's taking into account the 5 that have already occurred. So that'd be 15 more named storms. He's predicting 9 hurricanes, and technically Elsa, made a hurricane status, so that'd be 8 more hurricanes, and then 3 of those as majors, which is a Cat 3 or stronger. So if you think now we're already 5 weeks into the season, so the season's a little shorter, that's a busy few months ahead. And there's no reason to think it won't be. There's nothing that indicates the season is going to be slow. And I'm actually concerned about, in the end, being more impactful for the U.S. this year than it was last year, despite the number of storms that we had last year. And remember, people get all caught up in these numbers and how many storms there are, there weren't, and there are going to be. Realize we have better ways now to detect storms than we ever had. I can guarantee you there were years and stretches, just like there are now, back in the 14 and 15 and 1600s. We just didn't document it. So, and we didn't have the ability to do so. So that's, it's heavily weighted in the last 20 years because we just can find them better and know they're there, but it's debatable how valuable those numbers are. And to compare seasons now versus the 1990s, I think is a little muddy. There's somebody at the National Hurricane Center that would not like to hear that, but it's the truth. It does muddy the numbers a little bit. So it looks like a busy few months ahead, and so that'll keep you guys busy. as well. And we certainly appreciate everything you guys do and the information you get, the eyes in the field, which never stops being valuable. It's priceless. It really is priceless. And like I said yesterday, we're sure we had a tornado on the ground. All we have is a little piece of metal in I-95 so far, not knowing exactly yet what had happened and transpired. So I think with that, what are we at? 8:15. So yes, Roger.
I got a couple questions.
Okay, never doubted it.
The heat up north, the west,
Oh, yeah.
and over in the northeast, and then on the plane of that, don't do any of the
Tropics.
tropics.
That's a good question. So the Northwest, in particular, epic heat wave, record heat, literally. The Northeast, hot and some records, but not like the Pacific Northwest, where you're getting 110, 115 in Portland and Seattle. That's a great question, because Jacksonville, we are now on our 4th month. People probably don't realize this, but if you've lived here long enough, well, a lot of you live. We're on our 4th straight month of below average temperatures. We had a beautiful spring by Jacksonville standards. We had a cool June. It was actually about 1.5 degrees below average, which is fairly substantial. We haven't had a 90-degree day for 2 weeks until today. Hit 90 on the button, so just barely made it. The average high is 92 now, so it ought to be hot, right? So we've actually, as hot as other parts of the country have been, we've been really on this kind of island of relatively cool. And the reason I point that out is because that is how 2005 was, which was, again, a big hurricane season and impactful for the United States. And what we think the link is, because you have other parts of the country that are very hot and the oceans are not necessarily unseasonably warm. In fact, it doesn't appear that the oceans this year are going to be any warmer than last year, and maybe a little cooler. But remember, when we say cooler in the tropics, it's the water's still 83, 4, 5, 6. It's not cold. It's not cool. 80 is what we look at to support tropical systems. So, but what appears to be the case is that extreme heat at northern latitudes has a tendency to battle the cooler ocean waters and develop more instability, which is favorable for rising air, which is how a tropical system really develops out of its infancy.
There's going to be an El Nino this year.
Oh, great question again. Is there going to be an El Nino this year? Just today, issued by NOAA, is a La Nina watch. So the opposite, a La Nina. And we're coming out of a strong La Nina, which is what favored last year's big hurricane season, which is a cooling of the equatorial Pacific. Just to review it real quickly for you, cooling water over the equatorial Pacific has a tendency to lead to bigger hurricane seasons in the Atlantic because there's less shear, which is the enemy of tropical systems. So it appears that we could be headed back toward a La Nina, below average temperatures over the Pacific. And if we are, it may not affect this hurricane season so much, but it doesn't help it. We certainly aren't going to have warmer than average temperatures over the equatorial Pacific, which would increase the shear. So at best case scenario, it looks neutral, and it might even be a little less than that. So it looks like we're headed back to another La Nina. And La Ninas, by the way, typically have a dry spring here. And you'll remember how dry May was, even early June. It's hard to remember that because it's rained every day since June 15th, just about, right? But we came out of May into early June really dry. And that's the typical La Nina spring.
Third question.
All right.
They say, I know this is prediction ahead, but a lot of people talk on the news, not the news, but media, Facebook and other things that 2025 Miami should be underwater August 5th. Dallas is going to be at sub-0 degree weather with a huge snowstorm. Myths.
Does anybody know how often the terrible disaster in Seaside, right? The collapse of the condominium. There's been thrown out there that it was caused by sea level rise. Has anybody studied that or researched it for Seaside?
Well, I heard actually they had, if you remember, it was 2 days or 3 days before they had that explosion of the water off the day.
Well, yeah, that was Navy exercises.
Talk about that.
I haven't heard that one, but it doesn't surprise me. Yeah.
Well, it shook the building, which some of the concrete broke away from the rebar. It's no brainer.
Yeah. Well, there was also damage. There was some damage in New Smyrna because that was actually real close to the center. So, but throwing out there and I'll give another example. But how many times do you think that Seaside condominium's been underwater? It's 40 years old. In the last 40 years, how many times has Seaside been underwater? Underwater.
At least 40 times. Zero.
Almost a zero. In fact, it would be zero, except water has come into the garage. So, and maybe that had an impact. I don't know. But I'm telling you right now, that condo's never been underwater. All right. It's big. The pylons could be an issue. Exactly. Sure. But my point is, let's take St. Augustine. People tell me all the time there's sunny day flooding there all the time because the sea level rise and the tides are higher. How many times in the last 10 years on a sunny day has it flooded in St. Augustine? It's not zero this time, I'm sorry. But it's darn close. So you have to be careful with the stuff that's thrown out there. But so I'm going to say that in a few years, that's probably not going to happen, Roger. What's my point of that? Yes, in the back. Oh, okay. Any other questions? Yes.
Yesterday during the storm spin up.
Yeah.
Was National Weather Service having an issue with their weather alert going off? Because our weather alert radio never went off until the whole day, until after the storm was gone.
And you're in Duval? I didn't hear of that. I'll check with them tonight. I don't know. I didn't have ours activated because it was going off so much and we were on the air that.
Yeah, the phones were going off. I mean, those.
So you were getting your alerts on your phone.
Right.
Do you have NWS alerts?
The NWS radio didn't go off.
No, weather radio did not go off.
Most days, it'll just.
Yeah, Blair's is just
But
like.
today it went off for the test.
Interesting. I'll check on that. I have no idea.
I would just wonder because if that tornado went right over the top of our house before it came
It
down.
was, we saw it swirling
We saw
above
the
the
debris
trees.
field.
So are you somewhere near Mandarin or somewhere? Or?
No, we actually live.
By
close
Memorial
to
Hospital.
Memorial Hospital.
University.
We saw a bunch of.
So actually, it was after it had touched down already.
No, this was right before it touched down. You could see the debris floating right above the treetop level. It didn't hit the ground.
Right.
anymore.
But Bowden south of you then, right?
Yes.
So it had lifted already. It had lifted already. But that's why it had debris.
Well, we heard the transformer.
Oh, you bet.
Right after that.
Well, it was low enough, more than likely, because we could still see it crossing University, the debris ball. And in fact, by the way, that debris made it all the way to east of the airport. It wasn't still a tornado on the ground, but the debris made it in the air. Right, exactly. There's no question about it. And where you were would have been right after it. It had just lifted. You guys are lucky. It actually just lifted. So,
My phone went off.
yeah.
The first time it went off.
Yeah.
And I said, oh, I better make sure all the blinds are shut down.
Right, sure.
And as I was doing that, I just got mesmerized.
Right. Wow. That's a.
And then all the race and all the ham guys on there were
And you
tracking.
ran
I
out
ran
too.
outside, you could hear them tracking it coming down.
That's pretty cool. I mean, it's good for you guys. And by the way, that debris ball, when it looks real nice and centered, so to speak, and we know that there's debris being lofted into the air. Once that starts to fan out, that's when we're pretty sure the tornado's lifted, because now it's just simply debris up higher in the atmosphere that's being spread out by the higher winds.
It was like the size of our house.
Yeah.
Just
Yeah.
right above the tree.
And it was fairly large coming in, it was, I want to say, a couple hundred yards wide when it was doing the most damage. But by the time it lifts, they typically narrow. That doesn't surprise you. You didn't get any pictures, did you?
No, I was just done.
I know. I understand. Yeah. Yes.
Where did it cross University?
It crossed Bowden, and then it went across I-95, which tells me that'd be.
It was near Kennerly and University, I guess.
It's about the same. Yeah. It's about.
Yeah.
It would have been about University.
I'm about a half a mile from there. And
North or south?
Going west.
West. Okay.
I got, I think 14 mile an hour wind.
Yeah.
heard nothing.
Right. And the station is not that far from here, which means we weren't that terribly far from the tornado. And we had about a 20, 25 mile an hour peak gust of wind. Yeah, there was next to nothing. And you're right. There was it's very concentrated. Yeah. Yes.
Where are you coming off the river? I live over the Pickwick Park. I could have sworn I heard it wasn't a loud rumble, but it was a rumble like a truck in the distance, you know?
Yeah.
And everything was kind of quiet, and I just heard that, you know, it just stood out. And did it come in near my house?
Well, we had several water spouts that didn't apparently turn into tornadoes, but in the end, I got like 3 different videos of water spouts on the St. Johns River yesterday afternoon that until then I didn't even know existed. I thought they might, but I couldn't confirm it. So it's quite possible. Yeah.
It did come in somewhere in that area. Right?
Yeah, right. Came up from right along the St. Johns River over it and then moved slightly north to do it. And then one over Green Cove Springs, which I believe is the same cell, produced a big water spout just north of the Shands Bridge.
My wife wanted to go down to the gate room this afternoon. I said, no.
Yes.
Where are we with precipitation levels forms seasonal?
So we were way below average. We were actually pretty decent into February. Actually, real decent. We had a wet February. You might remember we had a couple of tornadoes then. And then March, we started to dry out, and really April and May dried out considerably. So going into June, we were about 5 inches below average for the year. But the problem was we hadn't gotten anything the first 2 weeks of June, and our evaporation rate is so high. That's what was drying everything up so fast. And now, it's a good question because the airport had 2 2/3 inches of rain yesterday. And I don't remember where we are now, but we were about 4 inches above average last week. So we must be somewhere around 6 to 7 inches above average at the airport. And then, of course, some places would be even more. So we're somewhere around a half foot plus above our annual rainfall.
So we're not in fire zone.
We are not at all. No. Yeah.
Where is the drop of radar at?
National Weather Service International Airport. It is literally in their backyard. And it's pretty cool. It's a big golf ball, you know, how they look. And so it sits there, and they've actually had to do quite a bit of work on it. They did a big upgrade recently, but it seems to be operating generally pretty well.
Now, all stations want to use that, right?
What's that?
All the stations use that?
Correct. All the stations use it and have access to it. Yeah, all of them. And sometimes that'll go down. So if you guys that use the radars that have those Doppler radars, then you're relegated to going to something nearby like Moody Air Force Base, Tallahassee, Tampa, or Melbourne. And that's okay, but it doesn't give you near as good a coverage. And the Doppler effect is really only good, arguably out to 50 or 60 miles. But really, I like it to be less than 50 miles. 40 to 45 miles is kind of the high end for the Doppler shift and finding the Doppler effect, being able to see how the raindrops are moving and what direction they're moving and how fast. Yeah, Roger.
Question, what do you think the chances are, like us getting maybe a group of us to come over on a Thursday night, that we would have on a meeting night, and touring your station?
That's a great question. We actually talked about that. A couple of years ago, we had, what we had started to do with emergency management were a lunch get together in May right before the hurricane season, and we invited you guys 2 years ago, but it's during the day. It's the middle of the day. It's hard for a lot of people to make it. We couldn't do it last year, of course, because of the pandemic, and technically the station has just now reopened to people, visitors, I should say. So that is a good idea. Would you guys all be interested in that?
Yeah.
So now you guys are a lot of people, but we could do we're on the air till 7. We could do a 7:30 meeting. I would really like you to see a broadcast or a part of a broadcast, but we can't support this number of people. But we could do a 7:30 meeting and do a 7:30 to 9.
We've got some months that we've got nothing planned, so maybe it's something that we can.
Yeah, we could.
Set up shop for November.
How long are your typical meetings? How long are your typical meetings? So 7:30 to 9, 7:30 to 8:30, maybe 9. Okay. I'm trying to think where else we could. Oh, well, we could go into we've got a couple of conference rooms that we could do, and then you can see the studio and the weather office and what we do to try to figure out what the heck the weather's going to do.
20 and 30 people at our meetings. Of course, when we say we're going to be at Fox News, there'll probably be a lot more, but that's fine.
Well, we've got several conference rooms. I'm off the top of my head what's the biggest. I'm not sure, but well, actually, we could.
I've seen the new setup. I've seen the new the last time I was there, you showed me where they would.
You don't need to have all this business stuff, just
Right.
the tour itself will be the whole night.
Yeah, we could do that, Billy. Yeah, you could just make it a tour of the station. Might be easier, actually. Yeah. Good idea. If you guys are interested, I think I could probably pull that off now as we get further away from the pandemic, hopefully, and then headed down the right road. Yes.
Normally, I feel that Floridian tornadoes are smaller than in Tornado Alley.
Typically, yeah.
But I think we'll be shocked at the number of tornadoes that Florida has per year, at least from some of the data I saw.
Oh, yeah.
What is that? Where does Florida rank in that?
Florida ranks like number 2 to Texas. So, and really it's because we have thunderstorms almost year round. So, and they're not typically the EF3, EF4, EF5 that you get in the plains or something like that. So we get a lot of little ones and small ones, typically not killer tornadoes, so to speak, or real big, but we get a lot of them. You bet. Yeah. And the Panhandle is a really big area that gets a lot of tornadoes. And then secondarily is a swath from like Tampa to New Smyrna is another swath that gets wintertime tornadoes relatively frequently. All right, you guys. Well, let's hope we're not talking tropics too much in the coming days and weeks and months, but I'm afraid we probably will at least a little bit. Tune us in on the station and on radio and TV and online. You got Talking to Tropics with Mike. I am always in contact with Roger. We're back and forth. Was there another question? Or yeah.
Just as a personal review, over the last several years, how have you ranked prediction-wise with the number of actual hurricanes that struck Florida?
As far as predicting each one and where they're going to go, is that what you're? Well, pretty much perfect. They come and go. Sally was a bugaboo for me. I thought Sally was a difficult forecast. Now, it didn't hit us, but it did hit the Panhandle, and I thought that was a very difficult storm to predict. Kind of came out of nowhere. It was an African wave. It was one of those, remember how I said, though, sometimes they'll just wait out that dust cloud, and when they get far enough west, they kind of start to get their act together. Well, this was an African wave. It was September. It was an African wave, but it didn't get its act together until it was in the Florida Keys. So that one to me was a bugaboo. That was tough. I've had some misses. There's no doubt about that. One of my better forecasts last year that I remember was a non-event was Eta, and that was in November. So we're deep into the Greek alphabet, which, by the way, is no more. They have a supplemental list of names each hurricane season they're going to use now, not the Greek alphabet. Because people apparently were getting all confused and stuff. Like when it got to Zeta, everybody thought that the Greek alphabet was over. It was the last one of the Greek alphabet. What were we going to do? Well, there's a lot more Greek alphabet beyond Zeta. But anyway, so Eta was coming up. And if you remember, Eta was going to come up right over Florida. And eventually, it was forecast to come up right over Jacksonville, which I was fine with that forecast. I was convinced it was going to be virtually nothing. I mean, nothing. Right? But it's coming up over Florida. People look at that cone and they look at the forecast and they're just like freaking out. It doesn't matter what I say. And including my own newsroom. I'll never forget this. I was on the air and it was Fox, so it was 10 o'clock news, and the advisory update came out. It was 10:45. And it takes it right in, it's the next day, and it takes it right into Duval County. And I can just hear people at home freaking out, right? So I'm sitting there, I'm like, how do I communicate this, right? And so out of nowhere, I'm like, there is no way in Eta this is a big deal, people. And for some reason that stuck, but it is the truth. And that one, I don't know if anybody even remembers it. It rained. We got a little rain. That thing went right over northwest Duval County. We might have got a 30-mile-an-hour wind gust. What happens when they get a late season tropical system like that, by the way, just between us, there's usually a really strong temperature inversion, and it's very difficult to get the winds aloft to break that inversion and get it to the ground, which is exactly what happened that day. It was not a real difficult forecast, but it was, in my eyes, one of my shining moments last year's hurricane season. But there have been some misses, and this one was a good, I've toot my own horn here, but Elsa was a good forecast. I never went Euro. We did have maybe some TV stations that did that for a while, but I could miss the next one by 1,000 miles. So But yeah, I've never really written, although I've got all my Talking the Tropics. Talking the Tropics with Mike started in 2005. And it started with Hurricane Dennis when it was in the, moving into the Gulf of Mexico. And I was like, it makes sense to me to have an update of the tropics every day. And that's where the Talking the Tropics was born. It was 2005. So it's been around for quite a long time. But yeah, there's some imperfect ones in there, to say the least. Yes.
Are your children saying you're getting ready to go to college?
Yes.
Are they going to follow in your footsteps?
No. But one is very science oriented. She's a STEM student. She's at Texas A&M, and she's actually studying.
Yes.
Oh, there you go. Howdy. She's studying genetics. She's interested in all sciences, so she's kind of interested in the weather, but not. In fact, she went to Texas A&M to get away from her dad's name. I'm like, honey, it's not that bad, is it? And then,
How far do you have to go?
right. Well, I threatened her. I was going to do a guest professorship because they got a great meteorology program at A&M. And I said, I'm going to go there as a guest professor and do some classes. She's like, you will not.
Wasn't that where one of your rivals went?
Yes. Tim Deegan graduated from Texas A&M. That's exactly right. He did. In fact, I talked to him right when she picked A&M. I talked to him and I bent his ear a little bit about A&M and all that good stuff, which was really good. It was nice of him to. Yeah. And the other one's doing nursing, which is a great calling too. So it's good. All right. Since you had the tornado go right over your house, you get the umbrella. Next time there's a tornado going over your house, I don't know if this will help. Well, thanks, you guys. I appreciate it. And thanks for everything you guys do. Thanks, man. Good to see you. Could you what?
Pinebrook Apartments.
Oh, yeah.
I moved there when I moved there.
Okay.
I lived in the one behind it, though, like I hit.
The ones that just got hit
The
yesterday?
one on the other side.
Yeah? Wow.
All right, guys. Appreciate you, Mike, for coming by.
Thank you, you guys.
We look forward to seeing you at our Christmas party.
Good to see you. Thank you.
We look forward to seeing you at our Christmas party.
Yeah, that's right. And you said December what?
December 11th.
You guys are planning things out so far in advance.
We do it on a Saturday, so
Which is better for me.
it's your day off.
Yes, we hope. I don't have anything on the calendar yet.
Yes, didn't last.
Paul, didn't you win last time?
Yeah, I slept early yesterday morning, about 6 hours, which is big for me.
Paul,
Yes, sir. I can hear you, Roger.
didn't you win something from Mike last time I had it delivered to you? Didn't
My
we meet
wife won that. My wife actually won it, but I won this one first.
Well, I have your umbrella, so we'll get together on the radio and I'll deliver it up to you. We'll meet up there at the Advanced Auto like last time.
You still got my number?
I think so.
Okay. Look, just hit me up anytime.
All right, sir.
Thanks.
No problem.
I appreciate it. Thank you.
Anybody want another 50-50 before we adjourn? Please see Billy. Please call me, see Billy, real quick there. Again, we are not meeting next month. Next month, it will be a month without a little vacation, basically. We'll be meeting in September. Those of you, again, we're going to be talking. We have a little presentation done by the Salvation Army, and then we can talk about helping out maybe in the grounds of here at the church. Me and Todd have talked about that.
Roger, I had an individual come by my house because of the antenna farm I have.
I'm sorry?
A woman came by my house because of the antenna farm that I have.
Okay.
And she wanted to come over and see if I could take her antenna down. She bought a house, don't want it. I went by and looked at it today. It's not the prettiest thing in the world, but it is a crank-up tower. It's got a moonraker on top of it, and it's got a rotor. It is free. So if you're interested in it, get in touch with me, email info@beltime.net, and I will give her your phone number if you're interested. She will call you. That's in Arlington. So it's free. It's a crank up CV tower. It's up to you.
Okay. Anybody else got anything else before we go? Let's do this 50-50 drawing and nice to see you, Steve. It's been a while.
Yeah, man.
I've
throw some QSTs, Olens, if they would like.
Oh, also, one other thing. Every month Peter has bread. He has tons of bread. If you walk out the hallway and straight, pretty much that diagonal, there's a room over there filled with donuts and pastries and all kinds of Italian bread and dry bread. Take it, because if not, it goes in the trash. And it's good bread. I mean, it's good for another couple more days. So they said pretty much diagonal right that way. It's going to take it. You ain't getting nothing. We'll talk about it in September. Talk about
Hey, Paul, are you still there?
Yes, I am. Can you hear me?
Okay, can you email?
No, it's not me anymore. He's getting it from Roger.
Well, actually, Rajesh had sent you my phone number. If you have it, you'll just pass it to Roger.
Oh, you sent it to me?
I sent it to the email.
Yeah, go. Why don't you go ahead and put your phone number in the
No, I
chat?
got it. I got it, Paul.
Just give it to Roger if you will. Thanks.
No.
Got some good pictures and I'll put on the Facebook.
All right, yeah, appreciate it.
Hey, what's going on? How's everything, Joe? Good. It takes a while. It takes a while.
Look, there was no bread over there.
No, I was looking for some too. Not at all.
Pradesh, you want me to step down?
Yeah, we're going to Whataburger.
Pradesh,
Yeah.
you want me to step down?
Yeah, I gotta check out.
Meanwhile, in New York City.
Start shutting down.
Hey, thanks, guys. Have a good day.
Bye, Paul. Good to see you.
All right, see you later, Paul.
Wow.